All right, here's the homework for sequences and series to have an understanding of them. All right, so this sequence is defined with the first term being 17. And then for each term thereafter, you're going to add 13 to that. So if you give the first 5 terms, the first term is 17, and then you just add 13 each time till you get to the 5th term. Here, the first term is 1/2, and it says, hey, multiply by -2, and then subtract 5. So 1/2 times -2 is -1, and subtract 5 is -6. -6 times -2 is 12. Take away 5 is 7. 7 times -2 is -14. Take away 5 is -19. And then 7 times, or -19 times -2, double it, positive 38. Take away 5 and you get 33. Here, first term's -1. The next term is 3. And it says take the two terms right next to each other and multiply them together to get the next one. So -1 times 3 is -3. 3 times -3 is -9. And -3 times -9 is 27. Here, the first term is 3. The next one is 7. And it says you take the second term and you go 2 times the first term. So that would be 7. And then 2 times 3. So 7 plus 6, that's 13. So then I would take 13, double 7, that's 14. So 13 and 14, that's 27. Start with 27, double 13, that's 26. So then together, that's 53. All right. 7, double it, that's 13. Oh, I know what I did. So in this case, when you go n subtract 2, you're going 2 back. So let's do it again. So it's 3 and then double 7. So 3 and 14, that's 17. And here, you have 7 and then double 17. So 34 and 7, that's 41. And then you have 41, 17 and double 41. So that's 82 and 17. That's 99. All right, write a recursive rule for each sequence, then find A9. So in a recursive rule, first I need to know what's the first term. Well, the first term is negative, but the first term is 7. Then, can you find a rule in terms of what you would do with the prior one? So if I want to find the next term, what do you do to find each one? So I think this is a typo. So I'm going to start here. This should say -7, or else it's not going to work. See, what you do is you take and you multiply the term before by -3. So take one term before, multiply it by -3 to get the next term. So there's a recursive formula. And then how would I find A9? Is that you'd have to find the term before A9. So I'd need to find the 8th term. So I keep multiplying by -3. So if I do that, I get 1,701. I get -5,103. I get 15,309. I get -45,000. So it's this one right here. So that one right there is the term before. So then you multiply that by -3, and your answer is -45,927. Here. So think of what we're doing to get each one that follows. So 15 over 2, then 6, 9 over 2, then 3. So what are we doing each time? It might be easier to change these to decimals so you can see it better. So 15 divided by 2 is 7.5. 9 divided by 2 is 4.5. 3 divided by 2 is 1.5. So if you look, we're actually just going down by 1.5. So if I continue that and go down by 1.5, I get 0. And then negative 1.5, and then negative 3. And then negative 4.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I found that. So the recursive formula would be negative 1.5 times the term before it, and then the ninth term is negative 4.5. So recursive one, you need to know the term before to use the recursive. Here, what am I doing? 1 to 2, 2 to 6, 6 to 24, 24 to 120. So what am I doing to get that number that I need? So it looks like I'm going times 2, times 3, times 4, times 5, and so on. So if I go times 2, 3, 4, 5, then I'm going to go times 6, and you get 720. Then I'm going to go times 7, and you get 5,040. Then times 8, and you get 40,320. And so the recursive formula is you multiply times whatever that term number is. So whatever the term number is, that's what you'd multiply times. So if I want to find the ninth term, I'd multiply 9 times the term before. And that answer would be, big answer, 362,880. Here, number 8, 4 to 8, 6 to 7, 13 over 2. It looks like you are, what are you doing? Oh, it's a tricky one. So you're adding the 2 together and then dividing by 2. So 4 plus 8 is 12, divide by 2. 8 plus 6 is 14, then divide by 2, and so on. So you have to add them together and then divide. You add them together and then divide by 2. Add them, and you need common denominators to make this happen. So in this situation, you would have 53 over 8, you'd have 107 over 16, and that divided by 2. So with common denominators, you'd have 106 over 16 and 107 over 16 divided by 2. So that's 213, and then a half, so it's 213 over 32. And I didn't show all the work getting common denominators here. All right, number 9. Give the first 5 terms of each sequence. So plug in 1, and you get 4, 2, and you get 1, 3. And you can see you're going down by 3, right? Is that it? Okay. Here, 1/2. So half take away 4 is negative 3.5, negative 3, negative 2.5, negative 2, negative 1.5. So you're going down by a half. We're going up by a half. They're negative numbers. Number 11, plug in 1, you get 4 over 6. Plug in 2, you get 8 over 7. Plug in 3, and you get 12 over 8. It's okay if you don't simplify. Plug in 4, and you get 16 over 9. And then plug in 5, and you get 20 over 10. And yes, you could simplify those. 6n to the half. So plug in 1/2 means the square root. So 6 times the square root of 1 is 6. And then it's 6 times the square root of 2. And 6 times the square root of 3. And 6 times the square root of 4. Well, the square root of 4 is 2 times 6 is 12. And then one more. And 6, and then square root of 5. 13, well, that's a tricky little symbol down there, so we'll have to explain what that factorial means. So if I plug in 1, I get 1 plus 1 squared over 1 factorial. So 1 factorial is equal to 1. So it's 1 plus 1, 2 squared, divided by 1, so the first term is 4. Then the next one, you'd plug in 2. So 2 plus 1 squared over 2 factorial. Well, factorial actually means you take the number that the factorial is and you multiply, counting down by whole numbers, to 1. So in other words, 2 plus 1 is 3 and 3 squared is 9. This is just 2 times 1. And so that makes 9 over 2. Let's try it again with the factorial. I think you'll see the pattern the next time. So 3 plus 1 squared over 3 factorial. So 4 squared is 16, and then 3 factorial is 3 times 2 times 1. So whatever the number is, you start there and you multiply, counting down whole numbers all the way to 1. And that's what a factorial is, not an exclamation mark. So that's 16 over 6. So do I have 4, 9 over 2, 16 over 6. If you plug in 4 plus 1 is 5, and square it is 25. And then you're going to go 4 times 3 times 2 times 1. So that's 25 over 24. And then one more time for 5. 5 plus 1 is 6. 6 squared is 36. And then it's 5 times so on. So you multiply this number by 5. 5 times 4 times 3 times 2 times 1. So we already did from 4. So times 5 is 120, and that's fine. You don't have to reduce it down. Number 14, plug in 1, and you get the answer, 7 over 1, which is 7. Plug in 2, and you get 28 on top and 9 on the bottom. Plug in 4, so 1, 2, 3. 3, so plug in 3. And you get 27 times 3 plus 4. So 81, 85. And then if you plug in 4 on the bottom, 3 on the bottom, you get 2 times 3, 6. You get 25. Plug in 4. And you get 64 times 3 plus 4. And on the bottom, so 4 is 64 times 3. It's 12. That's what? 192, and 4 more, 196. Put 4 on the bottom. What is that? 7 squared, 49. Believe it or not, that goes in evenly 4 times. One more time. 5 cubes, 125, triple 125, 375, plus 4 is 379. And then on the bottom, 10 take away 1 is 9, 9 squared is 81. So those are the terms. Some are easier than others. So write a rule, an explicit rule, rather than a recursive one, then find the 18th term. So here, when I look at it, 4 plus 7 plus 12 plus 19, and then 28. So it's 3, then 4, then 5, then what would be a rule? So when I plug in 1, the answer is 4. When I plug in 2, the answer is 7. So the rule is going to be n squared plus 3. Let's try that. So if you plug in 1, it's 4. If you plug in 2, yeah, 3 squared, and then so on. So it works. And then you try and you plug in 18. Some that like finding the pattern will like this. So 18 squared plus 3, so the 18th term will be 327. Can you find the rule for number 16? So this one we're just going down by 2, or up by 2, because the positive numbers are getting close, negative numbers are getting closer to 0. So we start with negative 23, and then we're just adding 2n every time. So if I put in 1, I need this to, for this to work, this needs to be negative 25. So if I put in 1, it's 23 and so on. Then if I want to find the 18th term, plug it in, you get 11. All right, can you see the pattern number 17? Well, I see 4 keeps repeating. Let's see. So if I plug in 1, if I plug in 2, if I plug in 3, so that's an. So if I want to find the 18th term, negative 4, 18 plus 2. Let's see, can you see the pattern? Some of them are tricky. So if I plug in 1, that's my answer, 2, 3, and it has to work for each one, not just work once or twice. So for this one, it's n squared over 2n plus 1. I know. And then, if you want to find the 18th term, you plug in 18. So once you have a rule, you can just plug in and get what you need. So it's 324 over 37. So can you write an explicit rule? Can you write a recursive rule for each one? So for this, the explicit rule would be 2 times negative 3 to the n minus 1, because you're multiplying by negative 3 each time. And the recursive rule, you would need to know what the term is before it. So for the recursive rule, it would be an, then it would be negative 3 times a n minus 1. So you take the term before and multiply it by negative 3. Number 20, negative 3, 2, 7, 12, 17. What's the pattern? And so I'm going to go and realize that it's adding 5 every time. So when I plug in 1, the answer has to be negative 3. So I'll have to start with negative 8 for it to fit. If it's a recursive one, then I take and add 5 to whatever it was before. So there's the explicit and there's the recursive one. All right, do a couple stories and then we're done. Elon makes time every day at the end of basketball to work on his free throws. During 1 week, he makes 11, 15, 19, 23, and 27 throws. Assuming the sequence continues, find the recursive and explicit rules of what's happening. So I see it's adding 4 every time. So the explicit rule would be you're adding 4 every time. So if we start with, I'll go back one. So if I start with 7, it would work. So 4n plus 7. So if I plug in 1, then 2, and so on. The recursive one, you would just say, okay, you're adding 7 to whatever it was before. So this one is explicit. This one is recursive. Florists selling roses. Their sales in the first 5 days are 3, 9, 27, 81, and 243. That looks exponential to me. So when I look at it, then I got to multiply that times 3, right? Or is it just 3 that? See, that one would work. So if I plug in 1, the answer is 3, but if I plug in 2, it's 9 times 3. No, that wouldn't work. So it's just 3 to the n. So if I plug in 1, it's 3. If I plug in 2, if I plug in 3, and so on. So that's the explicit one. The recursive one has to take the term before it. So what am I doing to the term before to get it? And that's the exponent. You're multiplying it times 3. So this one's explicit, this one's recursive. All right, one more. Rachel's friend was pushing her on a swing, and another friend measured her path. On the first swing, she went 32 feet, then 16, 8. So it kept going half, right? So explicitly, it would be 1/2 to the n. But you have to start with what you start with. So what you started with was, so if I plug in 1, that means it needs half of something. So what did we start with? 364. So if I plug in 1, the answer is 32. If I plug in 2, then it's half of that, right? 60. If I plug in 3, then it's half of that, half of half of half. So it works. So that's the explicit one. The recursive one, what am I doing each time? Well, I go 1/2 times whatever the term is before, right? In terms of it. So that's the recursive one. So you have an explicit one where you plug it in, and then you have one where you need to know the term before. All right, Mr. D Math, out. Good job doing your homework.